Hey, everyone, and welcome. I'm so excited for today's deep dive.
Me too.
Yeah, we're really diving into the world of AI,
Okay.
which I know you're all really interested in, right?
Yeah. AI is so hot right now. And particularly these
Right.
large language models.
The big ones, yeah.
The huge ones, yeah.
Like what's powering ChatGPT, right?
Exactly. Yeah, like what's powering ChatGPT.
Yeah.
And all the ones that
Yeah.
Google's using and everyone's
Yeah,
using.
but those take so much power.
So much power.
It's crazy.
So many resources.
It's wild. Okay, so we're actually not going to focus on the big
Alright.
ones today, right?
No, we are not. We are looking at the other end of the spectrum, which is tiny models.
Tiny models.
Tiny models, which is very much an up-and-coming area.
And that's what this this research paper is about, right?
Exactly.
Wow.
This is like the forefront. And what they're looking at, or like one of the things they're looking at, is this idea of algorithmic diversity.
Okay. Algorithmic diversity. All right. I think we need to break those down a little bit, those buzzwords.
Okay, so...
Like, start with algorithmic diversity.
Yeah.
What is that?
Yeah, so, I mean, essentially, it's this idea that you don't always need, like, this giant, complex model to get really good results.
Okay.
And a really good analogy I think they use in the paper is like, if you want to travel a short distance, you don't need to get on a jumbo jet.
Right, exactly. You could just walk, maybe.
Exactly. Like a bicycle would be much more efficient.
Yeah.
So it's finding that right size model for the task.
Okay, so how does this research, like, what are they looking at specifically with these tiny models then?
So they're looking at two very, very different approaches to building these tiny models, which is really interesting, I think.
Right.
And they're testing them on kind of tasks that relate to how we understand and interact with information, which I know is...
Yes, 100%.
Yeah.
Huge interest of mine.
A particular interest of yours.
Yeah. So, like, what kind of tasks?
So, I mean, like, things like document classification. So, you know, is this...
Okay, spam or is this not spam?
Right.
Things like information retrieval.
Oh, okay, yeah. Interesting.
Which is, like, essentially the basis of...
Findings.
Search engines, right?
Yeah. Finding the right stuff. Okay, so tell me about these two different approaches.
Okay, so the paper...
And the name of the paper, by the way, if you have it?
Yes. The paper is called Algorithmic Diversity and Tiny Models, Comparing Binary Networks and the Fruit Fly Algorithm on Document Representation Tasks.
Wow. That's a mouthful.
Yeah.
Okay, so we've got binary networks and the fruit fly algorithm.
Yes.
Yeah.
Binary networks or BNNs. And
BNNs, okay.
The FFA, Fruit Fly Algorithm.
Got it. So let's start with BNNs maybe.
Okay.
Like, what is that? So imagine a regular neural network.
Okay.
But instead of working with like a whole range of values, it just uses ones and zeros.
Okay.
So it's like a very
simplified,
yes, representation. It's like the difference between a really high resolution photo and like a line drawing. You're losing a little bit of detail, but it's much more efficient to store and to process.
So it's like putting the neural network on like an extreme diet.
Yes.
And it still works.
And it still works.
Amazing.
Which is the amazing part.
Okay, so that's BNS and then the fruit fly algorithm.
Mm-hmm.
How on earth, how can you use a fruit fly for AI?
This one's really cool. It's based on like really elegant biology.
Okay.
Fruit flies have this incredible sense of smell, right?
That's right, yeah.
Like
they love bananas.
They do, yeah. They can differentiate between thousands of odors with a surprisingly small and simple neural system.
Wow.
And this algorithm basically mimics that system to process and to categorize information.
So they trained this fruit fly system to do these...
Well, they built an algorithm based on...
Based on it, okay.
Got it.
To do like the document classification and information retrieval.
Exactly.
Okay. But why? Like, why fruit flies?
Because they're, well, I mean, remember how we were talking about like the efficiency of the tiny models?
Yep.
Fruit flies are like masters of efficiency. Mm-hmm. Their olfactory system can process like tons of sensory data with minimal energy. Yeah. And that's exactly what we want with AI.
Right. We want it to be efficient.
Exactly. We want to do a lot with a little.
Okay. So we've got these two different approaches.
Yeah.
BNNs and the fruit fly algorithm.
Yep.
And they're both about efficiency, but They're very different. So
Very different.
did they, like, pit them against each other?
They did.
Okay.
They did. Yeah. It was a real, like, AI showdown.
Okay, so who won?
Well, it's funny because it wasn't really a case of one being definitively better than the other.
Okay.
They kind of have their own strengths, right?
Okay, interesting.
So the BNNs were really good at those classification tasks.
Right.
So, like, deciding, is this spam or not?
Right, yeah. So it's a very...
filtering information, basically.
Exactly. It's like very black and white, right?
Yeah.
Whereas the fruit fly algorithm, this is the one that was really good at information retrieval.
Oh, okay, interesting. So, like, more about finding the right stuff rather than just filtering out the bad stuff.
Exactly, yeah. It's like...
yeah, that makes sense.
It's like having a bloodhound that can sniff out, like, the exact book you need in a giant library.
Wow. Okay, and are these both, like, way more efficient than the giant models?
Oh, my goodness, yes. Like, orders of magnitude.
It is more efficient.
Okay, so it's not just about, like, saving the planet. It's about making it accessible. Like, I could have this on my phone.
Yes.
And it wouldn't...
And it'll actually work.
Melt it.
Yes.
Amazing.
Yeah.
Okay.
Yeah, it's really cool.
So did they just, like, compare them, or did they try to...
So they also experimented with ways of making the fruit fly algorithm even better. Right?
Okay.
So, like, one of the things they did was they used this technique called PCA. PCA, yeah. Right. It stands for Principal Component Analysis.
Okay, and what is that? In, like...
Okay, so imagine you're trying
English.
to understand, like, a really complex painting.
Oh, okay.
Right.
Okay.
PCA is kind of like identifying the key brush strokes and the colors that really make that painting unique. Right, like the essential elements that define that painting.
Right, okay.
And it helps the algorithm do the same thing.
So it's like focusing on what's important rather than getting bogged down in the minutia.
Exactly. It helps it focus its energy on what's really, really relevant, which makes it even more efficient and accurate.
Right. So they're like... giving it superpowers, essentially.
Pretty much, yeah.
But it's so wild that, like, this all came from a fruit fly.
I know. It's amazing, isn't it?
It really is. It makes you wonder, like, what else is out there?
Exactly.
What other weird inspiration can we get for AI?
Like, what other hidden gems are there in nature?
Yeah.
Yeah.
I mean, this is all super interesting, but, like, what does it actually mean for, you know, me? The average Joe who's just trying to, like, find information and use these tools.
So imagine a world where, like, search engines are not only faster and more efficient, but they also, like, understand your unique interests and your information needs. Okay. So they can connect you to, like, really specific resources.
Okay. So, like, instead of giving me, like, a million results about something, it gives me, like, 10
really good ones
that I actually want.
Yeah, that are actually relevant to what you're looking for.
Okay.
Yeah, it's like having a personal research assistant who just, like, knows exactly what you need even before you ask. Well, and then thinking about, like, the accessibility. We talked about that a bit, right?
Yeah.
Imagine having AI tools on your phone that can, like, translate languages in real time or, like, summarize complex research papers for you, like, no matter where you are or what your internet connection is like. And this research suggests that those possibilities might not be that far off.
Wow. Okay. So tiny models, but, like, big impact potential.
Yeah, huge impact. And I think it just shows, you know, how important it is to stay open to new ideas, new approaches.
Because you never know where the next breakthrough is going
to
come from.
Yeah.
Okay. Well, this has been a mind-blowing deep dive.
It has.
As
always. Thank you so much for...
Thank you for having me.
For breaking this down. Oh,
it's my pleasure. It's so fun to...
learn so much from our conversations.
Yeah, it's great to talk to someone who's so interested in this stuff.
Well, I mean... it's fascinating. And for those of you listening, if you want to kind of dive deeper into this yourself, we have a link to the paper that we talked about in the show notes.
The show notes.
We'd love to hear your thoughts, too.
Yeah.
Like, what do you think?
Right.
Yeah. What kind of unconventional inspirations for AI can you think of?
Yeah. Let us know.
Yeah. Hit us up on social media.
Yeah, come find us.
Let's keep this conversation going on social media.
Until next time.